Hey Maddie, we started the birth weights project today, so I just kind of wanted to record this video just to give you some instructions and show you kind of how this works. This paper I gave out to the kids that has all of the birth weights on there, and India, we updated hers, was 3 pounds 9 ounces. So we're going to do some calculations with that. You can kind of ignore this top area over here because you guys have so many kids in class. I just decided to give you a separate sheet. So the first thing that we need to do when we get this stuff is to find the mean and the standard deviation. But I guess actually before we do that, we can't find an average and a standard deviation if they're 6 pounds 12 ounces or 6 pounds 7 ounces. So what we have to do is we have to convert each one to a decimal first. And ounces, there are 16 ounces in a pound. So when we're converting this 12 ounces to pounds, we would do like 6 point, and then the 12 ounces would give me the decimal. So it'd be like 12 over 16. And then I'd have to figure out what that is as a decimal. Give me a second. 12 over 16. And that's 0.75. I should have known that, but hold on. 6.75, that's what he would be, okay? If you go down here to like 7 pounds 6 ounces for like Ellie, okay, 6 ounces would be 0.375. So you can do all of the other ones that are 6 ounces, like 3 pounds 6 ounces would just be 3.375. So just kind of go through and do all of the 6 ounces ones and all of the 7 ounces ones, 8 ounces, all of that good stuff going all the way through, and it just makes it go a little bit faster, okay? So after converting those to decimals, we wrote these, we did the mean and the standard deviation, and for mean, we got 7.18, and standard deviation, when we put it all into a Google Sheet, we got 1.65, but let me check that really quick. Let me make sure it's 1.65. I know the 7.18 is right. 1.65, yes, correct. So then we fill in your data values on the bell curve, and we said, like, here's going to be the average. So 7.18 goes there in the middle, and then we just keep adding 1.65 and subtracting 1.65. So adding it here and here, adding it here and subtracting here, and then doing it again, adding here and subtracting here. And then we just figure out what each one of those numbers is, okay? And so then we have like these 3 categories, like 1, 2, and 3 over here. And this, the reason why I've labeled it as 1 is this is just talking about 1 standard deviation away from the mean. So it says the range that's 1 standard deviation away from the mean is going from what value to what value. So if we add 1.65 to this, I think it's like 8.83. And if we subtract 1.65, I don't know, it was like 5.53 or something like that. Let me check that to make sure. Yeah, 5.53 is what that number would be. So the range of 1 standard deviation would be from 5.53 to 8.83. Okay, now using that laminated sheet that you have, the percent of data that should be within 1 standard deviation of the mean is about 68%. Okay, that tells you the range from here to here. But then what we want to do is we want to look at the actual percentage. Ooh, something just happened. The actual percentage of our data that's within 1 standard deviation. So going from 5.53 to 8.83, how many of our values up here were actually between 5.53 and 8.83? So this one will be, any of the 6 pounders or 7 pounders will be between 5.53 and 8.83. 3.6 is, or 3 pounds 6 ounces is not going to be. 8.83, we don't know for sure about this one or this one. So you would go through and calculate all of those and figure out how many there are in that range, and then you would just convert that to a percentage. And I think it was like something like 76%. I don't know. You'll have to find out what that number is, but it's something close to 76%. Okay, and then you do the same thing for 2 standard deviations, 3 standard deviations, etc. Okay, Z-score, to find the Z-score for your baby weight, the formula for Z-score is your value. So this is me, this is your value, and then you subtract the average, and you divide by the standard deviation, and that tells you how many standard deviations you are away from the mean. So you, Maddie, were 8 pounds 9 ounces. Okay, so 8 pounds 9 ounces is going to be, I don't know, 9 ounces is this would be 8.5625. Okay, so you are not quite to the 8.83. You're about right here, so you're not going to be quite 1 standard deviation away from the mean. You're going to be like 0. Maybe 7, something like that. Okay, so go ahead and find the 2 decimal places for your z-score and figure out what that is. You're going to be approximately 0.7 or 0.8, something like that, and that's going to tell you what your z-score is. What's considered to be an extreme value is anybody that is larger than 2 standard deviations away or smaller than -2 standard deviations away from the mean. So you will not be an extreme value. So then just go ahead and label that. There are some people, I think like India maybe and Kelsey, they were less than 2 standard deviations away from the mean because they're 3 pounds and something ounces. Okay, so that's what that is looking like. And then on the back side, you're going to do a bunch of box and whisker plots. Okay, so these 2 here are box and whisker plots, and the odd number of data values is going to be with just you 17 students in the class, okay? And that's an odd number, so you're just going to take those data values, and you're going to find the min, max, median, Q1, Q3, all of that good stuff, okay? Just using this data. Now, what you're going to have to do probably is to put this stuff in order and maybe like list it off to the side over here would be a good idea. So Kelsey is the smallest baby. So she was 3.375. I'm going to list him up here, 3.375, and that's Kelsey. And then you just list off each one of them going down in order, and that's going to help you find your max and min and all that stuff for your box and whisker plot, okay? On the even number of data points, I wanted to do 18 numbers. And so what I'm going to do to make their 18 numbers, you're going to add in my data value. So you're going to add me in there just because finding the median and the Q1 and the Q3 is going to be different when you have 18 values than if you had 17 values. So I want you to look at that also. So my data value, you're going to add in, and I'm going to put me at the bottom here. I am Mrs. K, and I am 7 pounds, 10 ounces. Okay, and 710 was like 5625, I think. No, wait a second. 10 is just 7.625. So that would be my data value. So you're going to add me in there also when you're doing the 18 data values, and then you're just going to do a box and whisker plot just like normal, okay? The last box and whisker plot that you have to do is eliminating any outliers, and the first thing that you have to decide is what the outliers are. So the rule that we talked about yesterday is it's considered an outlier if when you're looking at your box and whisker plot, okay, here's your Q1 and here's your Q3, you have to take 1.5 times the IQR, and the IQR is Q3 minus Q1, and that, I'm just going to give you a little hint, Q3 minus Q1 should end up being a value of 2. Okay, so 1.5 times your 2 would end up being 3. So what you're going to do is whatever you get for your 17 students here, we're not using this data, we're using the data without me, you're going to take and add 3 onto your Q3, and you're going to subtract 3 from your Q1, and anybody who is beyond those points are going to be outliers, and you're going to delete them out. Okay, you're gonna get rid of those outliers. So I'm guessing the only ones that you're gonna maybe need to consider would be India and Kelsey. So you have to figure out if India and Kelsey are below this, and if they are, or one of them is, maybe one of them is and one of them isn't, you're going to delete them out, and you're going to calculate your min, your max, your median, your Q1, and your Q3 again, and do a box and whisker plot that eliminates those outliers and gets rid of them, okay? So just a little bit of a difference there. I know, I'm pretty sure you eliminate at least one of them. I'm pretty sure you eliminate at least Kelsey, maybe India, I'm not really sure. But calculate those and figure out what your Q1 and Q3 are, and then if they're below that. And then you're going to do a modified box plot, so getting rid of those values. Okay, so you should only have 16 or 15 numbers. I'm going to say or 15 numbers, depending on how many you eliminate for your box and whisker plot there. Okay, and then the last one is we want to figure out who corresponds to P30. And that's the 30th percentile. So when you're doing percentiles, we're going to take 30% or 0.3 as a decimal, and we're going to times that by 17 because there's 17 of them. And that ends up being like 5 point something. 0.3 times 17 is 5.1. Okay, but we always round up. So we want to find who is the 6th person, and they're going to be the person that corresponds to P30. Okay, they're in the 30th percentile. So going in order, when you have these in order, you're going to find who is the 6th person going down, and that's going to be the 30th percentile. Now then, what is the percentile value for your data point? To find out what percentile you're in, you're going to take the number of values below you, and you're going to divide by the total number, which in this case is 17. So whatever divided by 17, and then you're going to multiply that by 100 or just convert it to a percentile, and that is your percentile. You're in the whatever percentile. Okay, and that's how that works. I think that you and Jackson both have the same baby weight. So when you're calculating the number of values below you, you won't consider him to be below you. He would actually end up having the same answer as you would for this one. So you're the only two that are going to be that way. You're going to have the same percentile score, which is kind of weird. But anyway, since your value is exactly the same, you'll be in the same percent. Okay? All right, so hopefully that kind of helped a little bit. I'm going to be gone tomorrow, so I'm going to give you guys a Chapter 3 review, but you can continue working on this also. Just when I get back on Thursday, we'll go over questions on the Chapter 3 review. And I had planned on maybe testing over Chapter 3 on Friday, except I think we're going to have like an assembly for Mr. Moore on Friday at 9:30, and I think that's going to cut into our stats time, and I don't want to cut into the stats test. So we might end up waiting to test until Monday over that. Over Chapter 3. Okay, so there's that. Hopefully that made sense. Let me know if you have any questions, and that's all I have.